the workshop on text analytics for social data using Discover, Text, and Sifter. So the workshop speaker is Stuart Shulman. Unfortunately, he wasn't able to make it today, so that's why we're doing this over Skype. And hopefully everything will work out fine for that. If you haven't already, has everybody received the email for the Texifter? If you haven't or you have some problems, we have a student volunteer here that can help with that. Okay. Okay, that's fine then. Okay, so let me introduce Tsinghua, who's going to be the workshop chair. So, okay.
I'm Ping from Institute of Computing Technology, Chinese Academy of Sciences. So, welcome everybody to join the workshop on text analytics for social data using Discover, Text, and Sifter. And let me first introduce the speaker, Stuart Shulman. Stuart Shulman is founder and CEO of Texifter and a research associate professor of political science at the University of Manchester, Amherst. He is founding director of the Quantitative Data Analysis Program at the University of Pittsburgh and UMass Amherst, and associate director of the National Center for Digital Government. Dr. Shulman is editor emeritus of the Journal of Information Technology and Politics and the official Journal of Information Technology and the Politics section of the American Political Science Association. Okay, so let's welcome Stuart Shulman to begin this workshop.
Thank you very much. I want to first apologize for not understanding the visa requirements. I made it partway to Beijing, but unfortunately I did not have the correct documentation to fly into Beijing. So this was a mistake on my part, and I apologize for my absence. I thought I would just start by letting you know a little bit about who I am and what I do. So the first set of slides is very informal, and then we'll switch over to some other more substantive stuff. So just to start, I am a professor of political science. I've been doing research for about 10 years. And I'm sorry, Alvin, can you confirm that you can see my slides, all right?
Yeah, you can see that.
10 years into the problem of sorting public comments on proposed rules, I'll say more about that. In my teaching, we did a variety of projects related to citizenship on the internet, including projects that help elderly citizens learn how to use the internet during a period in the United States described as the digital divide, where elderly and other low-income citizens had limited or understanding or capability of how to use the internet, and my students would work with them in the laboratory to teach them basic skills. Just a little bit about me. I am now leaving academia and spending most of my time running my startup company based on the research we did. This is what my exhibit would have looked like if I had made it all the way to Beijing. Actually had a great big pile of t-shirts to give everybody, made it up with our product name in Chinese characters. It was very nice, and I'm just sorry I'm not there. I'm also a father and a soccer coach, and I'm very well known as a grower of garlic. I have a channel on YouTube where I put my videos about growing garlic, and I've been a dog owner for 25 years. And one thing I thought the Chinese audience might find interesting, I've also been reading Taoist readings for about 14 years. So every day I do a reading from I Ching, a book of changes, that helps me get through the day. So I thought you might be curious to know that you had a Taoist in the room today. Well, not in the room. So this is is the agenda for the workshop. First part is going to be slides, and I'll try to go through them as quickly as possible. My goal for today is to have you understand where the software comes from, what kinds of things it has been used for in the past, and what it is being currently used for now. Some of the theory of annotation science that is important, that informs architecture of our system, and in particular focus on what I call the 5 pillars of text analytics, and we'll say more about that. And then we'll take a break. Hopefully that will take us about an hour or so, maybe a little bit more, and we'll take a break. And then after the break, I've got a few more slides about some of the things you can do with Discover Text, but what I really would like to do is to get you using the system, and hopefully the Wi-Fi will support everybody getting on and creating an account and looking at some data together. And I'll give you a basic orientation to the core features of the system, and then we'll do some work together. I've got some data from Tencent Wiggle, and we will use that data for some examples of coding. We'll do together, and we'll look at the results all together. And then, time permitting, we'll also talk a little bit about Texifter, which is a Twitter tool, which you may find interesting as well. So, Alvin, any questions before we go forward?
Yeah, maybe we can, Pink can ask any questions from the audience.
Sure. There's no question, just begin. Just continue.
Okay, so I can bring up another deck. All right. Can you see the history of Discover Text now?
No.
No.
Okay, one second. Let me work on that.
Okay, cool. Yeah, we see it.
Okay. So, this project was a long time in the making. And certainly when I started, I had no intention of starting a software company or even ever building software. It was a lot of accidents. But what we focus on in our work is identifying what humans do well and what machines do well, and how we can build systems that link together as neatly as possible the work of humans and the work of machines. And so what we've tried to engineer is a kind of recursive loop where we can go back and forth between human input and machine input and produce better quality human observations and higher quality machine learning as a result. And so in everything that I'm going to show you today, the theme of iteration or trial and error, moving back and forth between humans and machines, will come up again and again. That's the active learning loop. So the history is a long one. When I first received funding, and I'll just confirm that the slides are changing, you can see that all right?
Yes, it is.
2001. My first research funding from the National Science Foundation was to look at the process whereby citizens contributed their opinion to regulatory rulemakers, and those rulemakers had to respond in a limited amount of time under the law to the public comment. And if the public created meaningful comments, the government is required to respond to those comments for promulgating the regulation. So this is a slide. What I did with the history slideshow here, I took one slide from every year of the research. That's what I'm going to share with you right now. So when we started, we were a theorist, a sociologist, a statistician, myself a political scientist, and we were looking at the role of the internet on how citizens could guide the regulatory process in the United States at the federal level. And back in 2001 and 2002, we were very naive and optimistic. We had a professor who was one of my teachers, John Dryzek, who is a theorist of deliberative democracy. So when we were first doing this research as social scientists, we were looking at the internet as something that enabled a better democracy, where people could deliberate, and different points of view could be heard. Maybe there would be some way to measure or operationalize a test of whether or not the internet made democracy better in the United States. And some of the things we were looking for were a wider variety of input, and people actually hearing and understanding the points of view of others. And in almost all respects, we were wrong. E-democracy did not have this effect at all. We could not find any evidence that the internet improved the quality of democracy. And after years of research, we ended up concluding something quite different. And so we failed to find what we were looking for. What was going on at the time in the US, this is now 2003, so about 11 years ago, they were launching portals. And this portal is still up to this day called regulations.gov. It's a place where they post all the public comments, and anybody can come to the site and leave their own comment. And it's required in the law that the government read every one of those comments, but when a comment is substantive or meaningful or important, it's required to respond. And so one of the concerns at this time was that by putting this process online, you might get too many comments. It might be too difficult to do the necessary review. And so we were funded to put together a team of researchers, begin to try and understand the problems. And what was going on by 2004, it was clear in the United States that mass email campaigns were being used by organizations to mobilize a large number of citizens to write comments. So if you see down here at the bottom of this slide where it says capital advantage, this little thing underlined in red, this was a counter that was live on this advocacy website. And every time someone would send a comment through their software, it would change into a tick, 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 tick. So this was 16 million public comments at one point. And the goal here for the groups was to generate as many comments as possible to make news, but also to raise donations, to grow the membership, to create public relations, to sort of drive public opinion. What was happening on the government end was they were receiving so many comments that were duplicates or near duplicates, very similar form letters. It was creating a problem for the government to sort all these letters. By 2005, we had come to the conclusion that the groups, and this is an environmental group, Sierra Club, for example, were simply using these public comment campaigns as a way to generate bigger lists of members that they could go to for donations. So we called this the smoking gun back in 2005. Smoking gun, it means the evidence, the proof of a theory. And our theory was that what was really important to the groups was not the comments, but the data. People were filling in their name, address, their telephone number. And we called this the smoking gun because the federal agency that they were sending the comment, this comment was about mercury pollution from coal burning power plants. They accepted anonymous comments, but here they said twice in their campaign that all fields are required, so they had sort of lied to the members. And we thought this proved that they were really out for the names and the addresses, because these campaigns were proliferating and groups were raising a lot of money, they were growing their membership, they were doing it through the public comment process, and in the public comment process, what counts is a very good comment. So if you send 1 million comments that all say the same thing, it only counts as one comment, and not a very good one. But if somebody writes a very good comment, and there's just 1 or 2 or 5 or 10, they're much more important because they're substantive. The way that regulations work in the US, or the way they're supposed to work, is that someone would have to write a comment that is substantive for people to take it seriously in the government. So by 2007, things had gotten very advanced in our research and in our development of some tools and some prototypes to deal with this problem. And there was a very, very high-profile issue around the polar bears. If you follow the global climate change and what's going on with the polar bears, they're projected to be diminished to very small numbers in the next 30 or 40 years because of loss of habitat. And so when the Fish and Wildlife Service announced they were going to list polar bear as an endangered species, this kicked off an enormous number of campaigns. I counted no less than 30 environmental organizations, like the NRDC, that had websites up where people could click to send a comment to the agency. And I became, at this point, very good friends with the gentleman who works in that agency, whose job it is to count polar bears. And instead of counting polar bears, his job is about to be sorting public comments. And so what we did, in cooperation with that federal agency, is we built an early prototype of what eventually became Discover Text. So back in 2008, this was a collaboration with a colleague in the computer science department at Carnegie Mellon University, Jamie Callan, who is a specialist in information retrieval. We built the first system for finding clusters of duplicate comments and near duplicate comments, and as this example shows, we built an interface for reviewing those comments. In the yellow would highlight places where a commenter had changed a form letter. The group would send out a form letter and changed it slightly or substantively. And we tried to make it easier for the gentleman whose job it is to read the public comments to only read the parts that are unique. And this technology is very similar to plagiarism detection. I don't know if you're familiar with that software. It's become quite popular in the United States. Plagiarism detection software looks at what a student has turned in for an essay and compares it to a broad corpus of essays that have been turned in over the years, and identifies places where a student may have used someone else's work without attribution. That technology for duplicate detection was fairly robust by this time, and we simply applied it to the process of reviewing public comments, and as you'll see later, works very well for reviewing Twitter as well. So by 2009, as a social scientist, I was starting to take notice of the fact that there was a lot of activity in the public comment sphere that represented commenters who were sending in 2 or 3 or 4 or 5 comments on the same campaign. So in the case of the Mercury, we had 87,000 people who sent two emails, 20,000 people who sent 3, and 5,000 people who sent 4, and so on. We would have one person who sent in 316 comments about a rule. So I coined this phrase, the plebers, because what the citizens seemed to but this was something we saw happening across a wide variety of public comment campaigns. About this time, I had started the company, and I had been reading some very interesting books. I'm a big fan of this gentleman, Jeff Jarvis, and his book, What Would Google Do? He's got another book on privacy called Public Funds I quite like as well. And I'm also a very big fan of Mr. Weinberger and his book, Everything is Miscellaneous. The Google book taught me to think about building a platform where other people could build value on top of the platform. DiscoverText is our platform for letting other people build value. I'll try and make that case as the workshop goes on. The Weinberger book basically said, in this new era, in the old era, say the metaphor is of a library, every book in a library has a specific place on the shelf. And that's the old, in the US, the old Dewey Decimal System. Every book has one place on the shelf. In the new world of digital data, the power of filtering means you can put things in different categories for different reasons at different times. And that's okay because filters allow us to build value out of that categorization. We're not as tied to the old notion of everything belongs in a single class. You can actually take advantage of different people categorizing things in different ways at different times. And then the James Blake book is just a wonderful book. I strongly recommend it. It's really one of my favorite books. I have the audiobook and the paper book. I've read it several times. I've listened to the audiobook over and over again. And my takeaway message about the history of information is that as it has proliferated, the demand has been, and the need, and the necessity has been for better filters. And so, as you'll see as we go through the workshop today, I have a position, an analytic position, that says most of what I do is build filters to deal with information overload, much like those public comments. When there are too many, you need specialized filters to allow you to focus in on small subsets of highly relevant documents and to more quickly dispense with the review of documents that are of limited importance or of no relevance at all to your task. And this is a major theme in my work and a major theme in our software. Concurrent to all of this work with research and starting of a company, I also was running a qualitative data analysis laboratory in a university setting. So we had spent years labeling text for the purpose of either doing social science research through traditional qualitative methods, or for labeling text for our computer science colleagues who were building machine learning models. And over time, I became more and more frustrated with the software that we were using, that we were licensing, commercial off-the-shelf software, because it did not allow us to do critical things that were very important in our time. For example, some of the software we were using in the early days of this research was very difficult to manage the data and to give the coding project to a variety of human annotators. The management of the data was tricky, the software was clumsy, there were all sorts of complications. We needed an easier way to distribute the work of coding across a group of coders, and also a better way to do measurement around that. In fact, the next slide deck is about my particular approach to measurement and the role that measurement plays in improving the quality of human annotation and machine learning that results from that annotation. And by 2012, we had become quite taken with a model that Professor Eric von Hippel had given a lecture about in a conference on the politics of open source as part of my work as a journal editor. Became very interested interested in this idea that crowdsourcing was a key driver of innovation. Professor Ron Hickle tells great stories better than I can about the history of innovation, which is his specialty. And his basic point is that most of the interesting innovation comes from users and not from inventors. So rather than things that I might dream up as an inventor, some of the most interesting things that happen with our software are actually innovations produced by individuals, groups, or crowds who are users of the software. Because I can't possibly anticipate all the different ways that people might use the software. It's quite diverse. So where does this leave us? So we've gotten sort of almost up to present time. And as a political scientist in the United States, there's a lot of interest in whether the internet or Twitter can shape an election, can bring down a government through a revolution, whether or not there are shortcuts to metrics that might enable us to better understand the successes and failures of political campaigns in the U.S. And in fact, a lot of focus on Twitter in the U.S. And we talked a little bit about Twitter during the workshop, but also about Tsinghua, some new data that we've been working with. But there is this sense, and it may be hype or it may not, that Twitter has become a very important agenda-setting mechanism for the media, for opinion leaders, and there are quite a few people doing work on predictive analytics, building explanatory predicting models about big events in politics and in entertainment and in consumerism, and looking to see if they can link what's going on in Twitter or other social media to that. So one of the interesting outcomes of this history that I've just shared with you is that the tool that we built for the public comments submitted to federal regulatory agencies actually turns out to be maybe equally useful or more useful for understanding what's going on in these big social media fora. Now, I always caution especially people who are new to doing this kind of work, I just caution people to be careful and wary about the possibility of turning everything over to the machines and not needing the human touch or human input to do good analytics. I mean, a lot of people, especially now in business, who are looking for a magic bullet so that they can develop an infographic or have a dashboard, do something in a fully automated way that drives predictive models or that allows people to do better research. And I'm very skeptical about that. I have spent enough time close to the data, reading it, consuming it, analyzing it, coding it, doing machine learning on it to know that there is a quintessentially important role for the human in the loop. And that aspiring to turn everything over to the machines is not a good goal because it won't work. And having said that as a caution, I will say that there are some places where the machines obviously make things much, much easier. So for example, the same technology that makes it possible for one federal government worker who counts polar bears for a living to review 600,000 emails also makes it possible for one individual to review 600,000 tweets and or other social media posts. Without having to change anything at all in our software, we were able to apply the duplicate and near duplicate clustering techniques to Twitter to get a better handle of what's going on in social media data and to speed up the process of generating insights, training machines as a result. Other things that you're going to hear a lot about today in the workshop include the use of search and filtering in text analytics. Those are 2 of the 5 pillars of text analytics. We use search a lot, we use filters a lot to make our job easier. And in fact, I tend to think of everything that I do, as I've said before, as a kind of filtering. We'll say more about that as we go on. This is an example you're going to hear a lot about today, which is, in the case of social media, there is a fundamental problem. And that fundamental problem is ambiguity in the language. Right, so our biggest research project on Twitter data is about tobacco smoke. And when you go to Twitter and you pull out 1,000 or 10,000 or 100,000 or a million, or as we did 100 million tweets that mention smoking, just a very cursory review will let you know that a lot of that is not about tobacco. It turns out there's quite a bit about marijuana, quite a bit about smoking barbecue. We have, in English, smoking hot boys, smoking hot girls, that's all pornography. And so there is this fundamental problem in the analysis of social data, that social data is very messy, that the language is ambiguous, and that even complex search queries using Boolean operators and various ways of constructing rules in your search queries can fail to adequately clean the data. And what we've seen in a lot of research is people are skipping over this problem of how do you clean the data and prepare it, and going straight to the analytics, often using automated tools. So for example, if I was to run an automated sentiment detection about smoking, and I did not clean the data first, I would find that smoking has a lot of very positive sentiment, because, to be quite honest, people love barbecue, they love smoking marijuana, they love pornography, they're very positive about it. And if you want to say something about smoking tobacco, and have people talk about smoking tobacco, you really need to build a custom machine classifier that can identify the difference between a tobacco tweet and all these other tweets. And so for us, the key is to keep those human coders active on the data, to help build the model. So for example, in this case, this is a screenshot from inside Discover Text. I was visiting Bloomberg News, which is a big, powerful news organization, and meeting with some people who were struggling with this problem because they had a mayor in Bloomberg and a Bloomberg News. And the mayor is always in the news, the former mayor of New York, lots of tweets, Facebook posts, and what they wanted to do was to strip out every reference to the mayor and focus on all the social mentions of Bloomberg News and Bloomberg products. And that really requires some human coding to train that custom machine classifier in an iterative process to produce a better filtering mechanism. So human coders, for us, are fundamental to the process. Another thing I'm going to teach you today is about a very unique sort of part of our system, probably the most unique part of our system, which is when we have a group of coders coding an item. So in this case, the item that was coded is this small post, and 4 coders have coded it as, yes, this is Bloomberg News. 1 coder has said, no, it is not. The process of adjudication allows us to go through and review coded data and to remove false positives. And in the process of doing this review, establish a gold standard. And by establishing the gold standard, we do a couple of things. One is, we're able to keep track for each individual coder on the likelihood that they're going to produce a valid observation. But then when we go to train our machine classifier, we're able to systematically exclude false positives. And through this adjudication process, we create better training sets, establish the gold standard, and come to better understand the coding problem. And one of the most fundamental lessons of my work in this area is that most coding problems are hard. There are very few slam dunks or very easy coding problems. The smoking one was particularly hard because everybody uses slang to refer to cigarettes and slang to refer to marijuana or other things. They're not being very clear in their communication. And so there can be a lot of boundary cases. And this process of going through and determining whether an observation is valid or not valid has the effect of educating everybody in this process about what some of the opportunities and challenges are in the coding. We'll say more about that. But really, it's this adjudication process, and I will come back to this a couple of times, and hopefully convince you, that allows us to see by code or by coder, and for a project, the likelihood of a valid observation. So in this case, I had one coder who was very accurate almost all the time, 97%. Another one, very accurate, almost to the same level. Myself, didn't much coding, but decently accurate. But here is an outlier, and we determined through adjudication that this one coder is wrong almost as often as they're right. So I go and talk to this person and say, Mike, what's going on here? You know, your coding is way off of everybody else's. And he had gone and done what we should call, I guess, independent research. And he had determined that Mayor Bloomberg was connected to Bloomberg business, and therefore every mention of the mayor should be included. That was actually contrary to the instructions, and kind of meant he wasn't paying attention. He's gone and made his own sort of judgments about that. But at least we caught it. When we went to train our classifier using the coding, we were able to exclude the 250 or so false positives that this one coder created that would undermine the coding process that we included. And that actually brings me to near the end of one of the main points is we use the measurement of inter-rater reliability, how two or more coders agree or disagree on it, to understand the difficulty of a coding problem. And we use the adjudication process to understand whether or not a particular code is going to be used in a valid way, or if we have some issues that we need to address. And this gets back to this idea of iteration, which I started with. The active learning piece of our system allows us to do some coding, to look at the reliability, to do some adjudication, and then go back to the coding, do some machine learning, filter the data, create a new sample, and go back and start again. And so we loop through this cycle, coding, measurement, machine learning, over and over again, until we fully understand the problem, and what the possible success and failure is with our annotation scheme, and we go from there. Ultimately, what we're doing is creating the basis for filtering more accurately. So, for example, if I train a classifier to tell the difference between Bloomberg News and Mayor Bloomberg, then I may want to go in and create a filter that says, show me all the items in my corpus that are above 90% likelihood to be about Bloomberg News, or not about Bloomberg News. And And we use those filters as a way to pull successive samples and to find false positives in the machine classification as well. That's where we start to really see the benefit of iteration and going back and forth between human coding, machine learning, and human coding, and machine learning is through the filtering process. We've actually built a specialized tool for its interactive classifier histogram that allows us to see the distribution of items based on their classifier score across the corpus. And using this tool, we can pull out specialized samples, sets of items for coding. And one of the things that Professor James Allen, who is a UMass professor of computer science, taught me is that within a particular collection, not all items are created equal, or not all are equally important for coding. There are some items in every collection at different points in the process that will add more value than others. And it's true, just like not all coders are created equal, not all items are created equal, not all codes are created equal, some are more important than others. And we use these filtering tools to pull out important subsets of items for coding that can speed up the process of creating a classifier. And so I've said to various people over the years that what I think text analytics is a series of data sets, a series of buckets, as you might call them, of text, and you move gradually towards a more trusted model that can be reused. And the goal is to build it once and use it many times. And the process of building it can be very educational. So that's the first set of observations about the history of Discover Text and some of the things that we do. I'm going to pause and ask if there are any questions.
Any questions from the audience? Maybe we can get a microphone and then maybe ping and repeat to Stuart.
Hi, Dr. Shulman.
Hi.
Thank you very much. I got lots of questions. I'm sure you answer some of them later on. I'm wondering, how the computing is done? Do you have access to large systems, or are you at that stage of scaling up?
I'm sorry. Could you the question closer to the microphone?
Or maybe ping him.
So please continue. I can repeat her question to you.
So my question is, I'm wondering what stage your software is at, whether you're at the stage of scaling it up, being able to process a large amount of data.
Her question is about your stage, the stage of your software. So what kind of scale your software can process, right? Maybe.
Yeah. Okay, good question. So the software is, I would call it a mature. It's been live and commercially available for 4 years over the web, but it is not a big data solution yet. I would describe it as a medium data solution, where the optimum number of units of text, posts, or comments is somewhere between 1,000 and 1,000,000, or 1,000 and 2,000,000. When we start to get into, because we are developing the .NET framework and using SQL database, we're not optimized for like crunching big data. But we do have some new development underway using Elasticsearch. And one of the things that I can share with you later or after the workshop is a prototype of our big data solution that that is in the early stage of development, but is much more robust with 100 million, 200 million, 500 million items than Discover Text is at this point. Does this answer your question?
Yes, thank you.
Thank you.
Yeah, I would just add that we are looking at ways to incorporate Elasticsearch capability into Discover Text. The thing that is holding us up for now is one, we're a very small company, so there's only so many things we can do, and the other one is that we don't have a huge demand for it. That most of the people that we work with on a commercial basis, even the academics we work with, are not using millions or hundreds of millions of tweets. They're using tens of thousands or hundreds of thousands.
So basically, you don't need to have to consider about the big data infrastructure, at least not yet.
Could you repeat the question, please?
Yeah, so what I'm saying is that you don't need to have to worry too much about the big data infrastructure yet. Like, for example, having to put onto like a Hadoop cluster or use like Amazon Web Services or something like that.
Exactly. We are currently hosted in the Microsoft Azure cloud, and we are not using any Hadoop MapReduce technology. The Elasticsearch capability I mentioned is actually running in a data center in the basement of my house. So I have a rack in my basement and some boxes down there, a disk array, and we're doing our experiments with big data off of the cloud and in a private cloud.
If you need some more machine power or so for Azure, talk to me, because since I work at Microsoft, maybe I can help you with that.
Well, I will say that Microsoft has been very supportive. We're in the BizSpark program, and in fact, we receive a generous subsidy already from Microsoft that makes our work possible.
Okay, very good.
Any more questions? Yes.
Shulman, one question about your software. Can use your software, you can say apply your software to do some text discovery search, like try to find the journal paper to see any work or any one topic among people's work, just something like that, based on the text.
So I think your question is about plagiarism, right?
Yeah, something like that.
So I think the question was about what kinds of data can be used in Discover Text.
Right.
And I actually do have some slides about that. So why don't I try and bring those up?
Okay.
Did I hear the question correctly?
Yes.
Yeah, and also too as well, if I heard correctly, also too about what do you do in terms of the text is copied, I guess, in terms of like plagiarism or so, to see if pieces of text are the same, or, right?
Yes.
Yeah. So we haven't done much work with longer documents like
Paper.
like papers or journal articles. We mostly have focused our work on large numbers of small documents, like social media posts, or open-ended answers on surveys, or the public comments on proposed regulations that I first discussed. I don't know what would happen, to be quite honest, if you tried to use our software for bigger documents. I haven't tried, and so I don't really know. It falls a little bit outside the scope of what we're focused on.
Any more questions?
Maybe so. So maybe I have a question. Maybe you've heard this before, but I'll just go over here. So Stu, yeah. So I have a question. You maybe heard this before, but are there any other companies or other competitors that are doing stuff similar to your software? And if so, where do you differ, or different than them?
Sure. So I think one of the main differences, well, there are a couple of differences. So there are a lot of companies in the text analytics space. Many of them are focused on fully automated techniques that minimize the role of human input. Some of them are dictionary based, so they are, developing dictionaries around things like hospitality, hotels, sports, pharmaceuticals, banking, and they are selling these services with I guess I would describe it as I try to with the volume down when I talk because I get an echo, with a bent towards knowing the problem in advance and architecting the solution of the software. I think the way that I would situate our work is that we assume that the problem is not known in advance, that from corpus to corpus data is very different, and this idea of building custom machine classifiers I think is a differentiator. A couple of other things that differentiate our work, certainly in the social media space, I have recently been doing some discussions with a large beverage company, I won't say which one, but they have used all of the other, the companies like Intensity, Clarabridge, IBM's products, SBS products. There are a lot of text analytics products out there on the market. And a couple of things that came out of our recent discussions. One was we give people more direct access to the data itself, to do things with the data and to different parts of the data. So particularly around Twitter, and hopefully with the Tencent Weibo and Sino Weibo as well, the ability to do things that fall outside of the kinds of queries that you can do in a Clarabridge, for example. So we've been doing a lot of work on filtering around people's bios. So if you're a mother and you're into sports and you also happen to drink Coca-Cola, let's say, we can pull those people out, either day forward or going back in time, and then we can build models of custom machine classifiers around very novel framing of a brand affinity or a product affinity or a topic affinity that maybe you couldn't have anticipated before you spent some time with the data. So we don't assume that every problem can be known in advance. We assume that part of the challenge and fun of doing good work is that you have to be sobered by the data and build a new model that is particular to what it is you care about, what you want to do. Alvin, does that answer your question?
Yeah, I think somewhat. I think it's okay. Let's have one more last question before we go for coffee break.
Yeah, I have one question. Actually, you talked about building, so we build custom classifiers, but you also talked about, you want to reuse the codes. So my question is, to what extent can you reuse the filters, or how do you do that actually? Because filters are related to the subject matters.
Sure. So I'm going to teach you how to do it. Later on in the workshop, but so for example, I've done some work with data from the insurance industry and sort of survey responses that were received from everybody who had filed a claim for a major insurance company in the US. And in working with that data, we quickly learned that there are really two big issues that are most important to customers of insurance companies, and they constitute about 80% of all the comments. And those two issues are price and service, right? So we built classifiers, for example, that can identify comments that are mostly about price or service, or price and service automatically, and then a category for everything else. Or maybe we'll have a category for no comment, a category for other. Yeah, and we built that for the insurance industry. However, it turns out that the price classifier works well outside of the insurance industry, as does the customer service. In our testing, we find that even though it was built for, the classifier was built for a particular domain, it may be possible to migrate that classifier to another domain, and it might not be perfect right out of the box, but with a little more training, the classifier does become robust. Another thing, so reusability can have two meanings. It could be reusable within the domain in which that classifier was developed, or it could be reusability beyond that domain. And in both cases, we've found that not having to go back to start from zero can be used. A price classifier, for example, if I just put a classifier, is this about price or not? Leaving aside service, other kinds of things, and no comment. Is this price or not? It's basically a spam filter for price, right? Where the classification is based on Bayesian, simple Bayes model. It's either in the category, it's out of the category, it gets a score, and so reusability for us means maybe building a library of spam filters around particular topics. Is this about customer service or not? Is this about price or not? You're going to see a lot of examples of, is this relevant or not? And in the coding I'm going to ask you to do in the workshop, we have some Weibo data about Malaysia, Ukraine, from right after the plane going down. The task is this about the plane crash? Yes or no? Or we have some examples for you from big American brands that are sold in China, like Starbucks, Microsoft, Coca-Cola, KFC. And the task that we're doing in the exercise today is for you to look at some items and to code them, whether or not they are relevant to Starbucks or relevant to Microsoft. And by building these very focused binary classifiers, we do create the possibility of reuse. And the mechanics of that is what I'm going to teach you in the live demo and in the workshop. In the part of the workshop where you'll be working with Tao and working with each other, frankly, because I'm going to get tired at some point. It's 10 o'clock here at night, so I'll hold out for as long as I can, but my goal is to get you to the point where you can do some of these things on your own without me having to be involved.